You can hear me and see my screen also. So today I'm introducing the watch method because it's really difficult to understand. So before starting this watch method, I just want to tell you where it lies. It lies between the clustering method where we use linkage, where we it is used where we can group them in separately to make clusters. So there we used words method. It have various methods also. Link has like complete, average, single method, and one of them is watch method. But why I have taken this method is because it's difficult to understand. That's why I'm making this video. So so before starting, I will take one example. So I will make one some data points in graph. So what are the steps are including in watch method is, so as you can see here, the start with the point in cluster by itself sum of squares error. So it the watch method is dealing with the sum of squares errors. The sum of squares, why it is squares, because when you are in graph, sometimes you deal with the negative values also to to remove those negative values. That's why we use squares. That's why. So uh, like I want to show you what is sum of squares is. Like there is one data point, and the difference between these data points it's called sum of square. But it the difference between of two data points in squares by for what it is squares, because to remove negative points. So I will just remove this link. Okay. So it will start with the each in cluster by itself. Okay. So I will count this one as a cluster, this one as a cluster, this one as a cluster, this one as a cluster. Okay. So like this for all clusters, this will have one singular cluster in initial, and this will have sum of square equal to zero, because this doesn't have any differences to calculate, because they are itself one data point. So next step. So what is the next step? Merge two cluster in order to produce the smallest increase in squares. So those who have smallest increase in sum of squares, we have to merge them. So difference between these and these in smallest. So if I calculate difference between this data point to this data point as 2, and difference between this data point and this data point and this data point as 3. So as sentence has said, the merge two clusters between in order to produce the smallest increase in the sum of squares, the smallest merging cost. Merge two clusters. Okay. So I have got two in the smallest value in the terms of 3. Okay. So I will merge these clusters. Okay. So this merging is called merging cost, the smallest merging cost. Okay, because the smallest merging cost, because why it is called small, the difference between two data points, those who have smallest, that cluster will merge. Okay, so then keep merging until you reach k clusters. Okay, so keep merging until you don't have any data point to merge it. Okay, so then I will calculate this cluster with this. Okay, if I found this one as a 1, so the smallest difference is I've got is, so sorry, before doing this, we have to take out this median. Okay, median means center of this point, mean, median, anything you call it. And we have to calculate the variance between them. Okay, because why we are doing this, because we want something to denote this cluster, this big cluster. Because how we can calculate between this cluster and this cluster? Okay, we want something value to calculate, so that's why we are taking a center point, and by taking center point means we will take value as the variance of them, and we once we got the center point, we will calculate between this and this distance, this and this distance, this and this distance. So those whoever got the smallest one will merge with them. So if I got the this median or mean, the center of the point, I will show you in the document where it is written. Okay, so see, you can see where mj is the center of the cluster of j. Okay, so it has the it will have the center of each cluster. So if I calculate this data point with this, I will just write in the new, because you will confuse. Okay, if I have like this, okay, and in initial everyone have their own cluster, everyone will have their own cluster, and the sum of square will be zero. Just denote this point, note this point, everyone will have sum of square will in zero. And then those whoever got the smallest sum of square will merge to them. So I found these two data point in the smallest sum of square, so I will merge with them. Okay, but then what I will do, I will take the center of this cluster. Okay, so I found this cluster, center of this cluster somewhere here. So these cluster this cluster will represent this data point. Okay, so this cluster will represent other data point as this point. So I will calculate the distance between this data point, this data point, and this data point. Okay, so those whoever will get the smallest will merge to them, means at the end will merge to them. So if I got this 1, 3, and 2, so one is winning here, so I will merge with him. So again, I have to take a centroid, a center point of this cluster. I will found somewhere like this here, and now this cluster, this big cluster, will represent other point. Okay, so I will uh, count the distance between these and count the distance between these, and is suppose I have got this cluster with the smallest sum of squares. So okay, now this is winning. Okay, so I will calculate the centroid of this cluster. Okay, so somewhere I will go here. Okay, so then lastly the difference between this, the clustering is done. So why we are using this word method? So what method is using something called as the merging cost. The I have told you the merging cost, what it is, the smallest sum of squares, those who have it will burst to them. One more example to understand you about the what's a method. Suppose it have a five data points to cluster with them. So the smallest increase in sum of squares, I found this. Okay, then I have calculate the centroid of between these data point. Okay, and now next time when I calculate with other data point in the terms of smallest sum of square, I have found this data point is the smallest, so I have merged with between these. Okay, and then other data points also, they have the I have calculate um, the smallest sum of square. I found this cluster to be one, and calculated the the centroid of this data point, and I've calculated distance between these and these. Okay, and I found this to be as one cluster, so it has made. Why this cluster is important, I have told you, because of balance and separation. Okay, why what methods it's like more beneficial to use, because it's easy to identify the groups, because it identifies it identifies the difference between the balance and separation, because when when the data points are far more away, it already awares about this is different cluster and this is different cluster. So that's why it easily identified to become to identify the clusters. But why there is a disadvantage between the single?